Welcome everyone to our program on electric vehicles and charging in Nebraska, presented by Randy Smith. My name is Peggy Apthorpe, and I am currently working as an AmeriCorps with Conservation Nebraska. Conservation Nebraska is a statewide nonprofit dedicated to keeping our natural resources healthy. And we do that in a number of ways, including public education programs like the one that we are having tonight. To learn more, check out our website at neconserve.org, our Facebook page, or our YouTube channel. We do record all of our programs, and they will be, like Randy's program tonight, will be on YouTube probably in a couple of weeks. Some housekeeping information before I introduce Randy. Your microphone is off and your camera is also off. If you have questions or comments, please put them in the Q&A or the chat, and we will address them at the end of the program. Also, we will put up a short survey at the end of the program. We would appreciate your taking time to complete that because it helps us with planning and funding types of issues. Well, we're very fortunate to have as our presenter tonight, Randy Smith. He has been an environmental specialist in the Planning and Aid Division of the Nebraska Department of Environment and Energy since 2016. He manages grants related to air quality and reducing diesel emissions, including administering Nebraska's share of the Volkswagen diesel emission settlement. He has designed and administers Nebraska NDEEs. I think there may be an S on it now. Randy can tell us that, but electric vehicle charging infrastructure rebate program, which is using 1.8 million of Volkswagen funds to partially fund 28 projects that will create 35 new EV charging locations across Nebraska. I think recently he's been involved in a number of other projects, which he can tell us about, hopefully a little bit later. Randy holds a Bachelor of Arts degree from Cornell and a graduate degree from the University of British Columbia and the University of California, Santa Cruz. He has experience as a geologist, educator, GIS specialist, and technical writer, in addition to his work with the Nebraska Department of Environment and Energy. So we really appreciate your being here tonight, Randy, and I'll just turn the program over to you. And thanks all of you for being here too.
Okay, thank you, Peggy. We can change the discussion on that EV charging rebate program. That is concluded. That went on from 2019 through 2022. We did achieve close to the targets that were mentioned there in Peggy's introduction. The other part of my qualifications for this presentation is since March of last year, I've been driving a Kia EV6, all-wheel drive, which is billed as an electric SUV, but it's really a large hatchback. But it's a fully electric vehicle, which is going to be the focus of this presentation. We're not going to cover plug-in hybrids. They have much smaller batteries and less intense charging needs. What I do want to go through is to briefly go through some advantages of electric vehicles and driving electric vehicles, battery capacity and driving range, charging your electric vehicle, and some shopping tips for EVs and home charging equipment. Okay, so it's remains an exciting time to be thinking about an electric vehicle. There's lots of new models that have come out in the last few years from traditional manufacturers as well as from new specialty companies. All types of vehicles, sedans, SUVs, pickup trucks, luxury cars, and there's even a few hypercars out there that are electric. EVs are really amazing examples of technology. So here's sort of a cutaway version of a generic electric vehicle. Most of them have either one or two electric motors. A single motor EV will have the motor mounted on the center of either the rear or front axle. Rear-wheel drive is more common, but there's a few that have front-wheel drive. A dual motor EV has a motor on each of those axles, so that gives you all-wheel drive. All-wheel drive EVs generally will offer different driving modes that might give different combinations of that motor use. In my EV6, there's an eco mode, which is rear-wheel drive, except for a second or two when you accelerate quickly. There's a normal mode, which is still mostly rear-wheel drive, and there's a sport mode that is full-time all-wheel drive. So even if you have a dual motor EV, you have some control over how those motors are applied. The motors are also mounted parallel to the axle so that the rotary motion of the motor is transferred to the axle by a very simple reduction gear transmission. And so that the motor in each axle drives both the wheels on that axle. There's a few other options out there. Some Teslas have a tri-motor option, where there's a motor for each of the two rear wheels, and then the third motor is mounted on the front axle. So that gives you a little bit more control of the two driving wheels in the rear. There's a few high-end vehicles that have an individual motor for each of the four wheels, but that takes a lot of software gymnastics to keep everything in sync. Some other components, there's obviously the battery pack, which is the yellow thing in this illustration. That provides the electricity that drives the motors. May not realize this, but EVs also have a standard 12-volt battery as well, which powers everything else except the driving wheels. So the lights, the infotainment system, all that's operated from the 12-volt battery. There's a thermal system to regulate the battery pack temperature and the cabin temperature, so heating and cooling. There's an onboard charger coupled to a battery management system to manage the charging of the battery pack. And not shown in this illustration, EVs all have regenerative braking systems to turn that rotary motion of the wheels and axles when you slow down to generate electricity to partially recharge the battery pack. So just like a Toyota Prius. So what are the advantages of electric vehicles? For homeowners, most of your battery charging can be done at home. And no more trips to the gas station. There's less maintenance and lower cost to operate because EVs have far fewer moving parts than a conventional vehicle. These electric motors provide more or less instant power. So you get very quick and very smooth acceleration. You're not shifting into different gears and having that moment of hesitation while the gear transmission shifts. It's a very smooth driving experience. The powertrain overall is a lot smaller. You have one or two smaller electric motors on the axles instead of a big internal combustion engine in the front or rear of the vehicle. So there's no drive shaft running down below the cabin. The cabin floor is flat and generally bigger, generally more space front to back because of the absence of a big engine. And the batteries are mounted low in the chassis between the axles. So most of the weight of the vehicle is centered and very low, which provides better handling. So as we said, electric vehicles can be charged at home or at public chargers, but in order to understand charging, we have to get into a little bit of electrical terminology. Have to understand kilowatts and kilowatt hours. So basically, you might see a rating of a piece of charging equipment, the charging power, which is basically equivalent to how fast is electricity being transferred to your battery. It's a rate of energy transfer per unit time, and that's expressed in kilowatts. On the other hand, the battery capacity is a measure of stored energy, and that's measured in kilowatt hours. So 1 kilowatt hour is equivalent to 1 kilowatt of charging rate sustained for 1 hour. So when you're shopping for an EV, one of the things to look at is what's the battery capacity? And that has tended to increase through time. Generally, the larger the battery capacity, the longer driving range you're going to get. This chart shows some battery capacities that this is a few years old, and some of these numbers are drawn from the internet, but the first popular commercial EV, the Nissan Leaf, basically had a 40 kilowatt hour battery pack. The newer Leafs have slightly larger batteries. The original Chevy Bolt had a 65 kilowatt hour battery. I think the Bolt EUV has a little bit larger battery. There's a lot of mid-range EVs that have battery capacities between 75 and 80 kilowatt hours. Above that, you starting to get into higher end vehicles. The extended range Mustang Mach-E, about 100 kilowatt hours. The long range Tesla, the same, and even higher capacities for some more expensive higher end vehicles. US EPA actually publishes estimated driving ranges for new EVs. These are actually the result of testing that's designed to simulate a combination of city and highway driving. They're weighted a little bit more heavily towards city driving than highway. One of the facts about EVs is that unlike a conventional vehicle with an internal combustion engine, EVs actually get better mileage in stop and go city driving than they do on the highway. When you're driving in the city, stop and go, you have a lot of regenerative braking that can recharge your battery as you drive, which extends the range. You're also driving at relatively low speeds where drag from air rushing over the vehicle doesn't play much of a factor. But at highway speeds, that aerodynamic drag reduces efficiency. And when you're driving the highway, you're not slowing down very much, so you get less regeneration. So if all you're driving is local around town, you may get more range than the EPA value and more like what the manufacturer claims. On long trips on the highway, you'll likely get less range than the EPA value and less range than the manufacturer suggests, and probably less range than the vehicle's predicting. A lot of EVs will show, here's how much range you have left, but that's generally based on your kind of recent driving habits. So if you've been driving around town most of the time, then you suddenly go on a long trip, the initial driving range the vehicle shows you is probably an overestimate, and it will gradually change through time and become more accurate as you drive further on that trip. Well, there's a lot of things other than size of the battery pack that affect your driving range. Are you driving in two-wheel drive or all-wheel drive mode? How big and how heavy is the vehicle? What are the aerodynamics of the design of the vehicle? Are you running the air conditioner in the summer or heating the cabin in the winter? Cold temperatures in generally are going to decrease the range because the battery pack likes to be at basically room temperature. So when it's 10 degrees outside, the car has to draw current from the battery to heat the battery pack and just keep it in normal optimal operating mode. So that's going to decrease your range. Is it windy out? Wind will increase drag in the vehicle and slow things down. How are you driving the vehicle? What driving mode have you selected? And just how are you driving? Are you driving sedately like grandma, or are you driving like a race car driver? Another factor may be the size of the wheels. Some studies suggest that this has an impact. Wheel sizes, when you buy your EV, may vary from like 18-inch diameter to 22 inches. The tire diameter is the same. So the bigger the wheel, the less tire thickness there is. So they generally have to make the tire wider, which means there's more tread in contact with the road, and the larger wheels themselves are heavier. So some of these studies suggest that you're going to get more range with a smaller wheel size and a conventional tire. So charging your electric vehicle. Again, for homeowners, most EV charging can happen at home, overnight, for daily commuting. For road trips and renters without access to home charging, public charging stations are obviously going to be needed. There are 3 levels of EV charging based on the electrical characteristics of the equipment, which affect how fast you can charge. So level 1, as the name implies, is the lowest level of charging. There is actually no external charging equipment. There's basically a charging cord that likely came with the vehicle. One end has a specialized connector that plugs into the port on your vehicle, and the other end has a standard plug that plugs into a standard 110, 120 volt alternating current outlet in your garage. So in this case, the EV's onboard charger converts that current from alternating current to direct current, which is what the battery pack needs. And this is a relatively slow charge, 10 hours of charging to get 20 to 50 miles of range. Now, I'm mostly charging my Kia via level 1 in my garage. I have a 12-mile round trip commute to work that is about half city streets and half interstate I-80. I get about 3 miles of in-town driving range back for each hour of level 1 charging. So about 4 hours restores the charge from my daily commute. So I don't plug in every night. Generally every 2-3 nights I can plug in, and in that 12 hours, I'm fully charged again. Level 2 charging is a step up. It's still an alternating current piece of charging equipment that requires a 240 volt circuit. This would be similar to what you'd have in your home if you have an electric dryer. There are both home level 2 chargers and commercial or public level 2 chargers. Again, the equipment is providing alternating current to the car, so the onboard charger has to convert that to direct current. The power rating for these is generally between 3 and about 19 kilowatts, so quite a bit faster than a level 1 charge. 25 to 30 miles of range per charging hour. There's a standard connector called a J1772, which is used, pretty much universally for level 2 charging. Public level 2 charging, you'll find at places like motels and restaurants, shopping centers, city parking lots and garages, places where you're going to be parked for an hour or 2 or more. So you get a substantial charge during that period of time. Home level 2 chargers can be purchased for starting at about $400 for a so-called dumb charger that is just charging the vehicles. You can pay considerably more for a smart charger that can connect to your smartphone and schedule your charging session to take advantage of times with lower electricity rates. But most EVs let you do that directly through the car's onboard infotainment system. And the vehicle manufacturers provide their own smartphone apps to let you monitor the charging and notify you when the car's fully charged. So in my mind, the smart home charger is sort of an overpayment. And finally, we have DC fast charging, sometimes called level 3. These are only public chargers. These require very high voltage AC input from the electric grid to the charging equipment. And the charger then converts that to direct current. So that bypasses your onboard charger, but it still runs through the car's battery management system. These are chargers that can provide between 50 and 350 kilowatts of power. The original fast chargers were down around that 50 kilowatt rating. Now it's more like 62 to 125. And there's a few that are up to 350 kilowatts. So with this, you can get 100 miles or more per range per charging hour. The tricky aspect with DC fast charging is there are 3 different connector types, and the connector landscape is changing very, very rapidly and seemingly constantly. So most current EVs, other than Teslas, use what's called a combined charging system. This is it's combined because it includes that level 2 J1772 in the charging point and the DC connector. So these vehicles have a single port that handles both level 2 and fast charging. There's an older standard that was used initially by Nissan with the Leaf, and followed by some of the other Japanese and Korean manufacturers, called CHAdeMO. It's only a DC connector, so those cars need a separate level 2 port for charging. The CHAdeMO standard is rapidly going away. I don't think there's any currently manufactured vehicles that still use CHAdeMO, but a lot of the public DC fast chargers will have both a CCS and a CHAdeMO charging cable on them. That's probably going to change over time. Tesla went its own way. Their supercharger network used their own initially proprietary DC connector and port. In the last couple of years, Tesla has opened up that the specs for that connector, which they build the North American charging standard. Because Tesla's charging network has a very well-deserved reputation for reliability, some of the major car manufacturers are switching from the CCS connector to the North American charging standard connector. So that's going to be a transition we'll be seeing in the next few years. Tesla is retrofitting some of its superchargers with what they call a magic dock, which will accept either the CCS connector or their Tesla connector. But those are being rolled out very gradually across the country. So all these connector standards include very complex communication protocols. So plugging a charging connector into the charging point in an EV is a lot more complicated than plugging an appliance into an electric outlet. The charger, external charger, and the EV's battery management system communicate to each other, control the charging power and the speed. So each one knows the other's capability, and the charger can only deliver as much power as the car can handle. So there's just a lot of safety protocols built into these charging systems. So the external charging equipment may have a maximum rate. We've seen they go up to 350 kilowatts, but in most cases with those high-powered chargers, it's the vehicle's battery design and battery management system that set the maximum charging rate. And that varies with the EV model. So a chart on the right-hand side of this shows some data for some example vehicles. Going back to the original Chevy Bolt, the maximum power rating for charging in that was only 55 kilowatts. So you plug that into a 350 kilowatt charger, and you're really not getting the full capacity of that charging equipment. Some of the more recent vehicles, like the Volkswagen ID.4, top out about 125 kilowatts. The Mach-E is a little bit faster. The Kia EV6 and the Hyundai Ioniq 5, which are built on the same charging platform, have about a 240 kilowatt limit. My charging sessions on 350 kilowatt chargers, I've gotten between 150 and 180 kilowatt charging rate, which is pretty good. And again, there's a few high-end vehicles that allow much faster charging. There's other factors that will influence this, like the outside temperature, the temperature of your battery, and the state of charge. Some manufacturers will look at the state of charge of your battery. Oh, you've got 50% battery charge, so we don't need to give you full power. We'll give you somewhat lower charging rate. All that is basically up to the car manufacturer and how they think fast charging should be handled. Another component here is that charging rate will vary during the session, and that's again controlled by the car's battery management system mostly. So the batteries are happier and will last longer if they're charged slowly. Rapid high-power charging is hard on the battery and can shorten the battery life. On the other hand, you would like the car to charge as fast as possible so you can get on your way. So the manufacturers are trying to balance those two competing factors here to balance convenience with longevity of the battery. So this chart, which I stole from ChargePoint, which is one of the major network charging manufacturers and network managers, shows an idealized charging curve that assumes that the battery pack is starting out empty, which is going to be pretty rare. So initially, the charging rate slowly increases as the battery warms up. Then it'll top out at the maximum rate that the battery management system wants to set. And ideally, it'll maintain that rate to about 80% charge. And then in order to minimize the impact on the battery pack, the charging rate will slow down. And how it slows down varies greatly between manufacturers. And in newer external charging equipment, the external charger may also influence this. There's a very common strategy among travelers with EVs. It can take as long to go from 80 to 100% charge as it did to get you from 20 to 80. So driving the interstates, people they'll charge to 80%, and when the charging rate goes down, they'll unplug, go on to the next charger and do it again. That's okay if you're on the interstate where chargers are fairly frequently spaced. But if you have to go off the interstate into an area where there's not much public charging, you may want that full 100% charge. So you just be aware you may have to go through a slower final period of charging as that charging rate slows down. So where can you charge publicly? So here's a map of public charging locations in Nebraska as of this month. So the blue dots are public level 2 charging stations. Most of those are kind of clustered in the eastern part of the state, kind of gradually radiating out from the I-80 corridor. And there's a few in western Nebraska as well. The red triangles are Tesla supercharger locations. Those are all along Interstate 80. So those are out around, I forget where the one in far west Nebraska is, but there's one in Ogallala, Kearney, Grand Island. There's one in Lincoln, and there's one in Council Bluffs on Iowa, on the Iowa side of the river as well. But they're only along the interstate. The square symbols are DC fast charging stations for other EVs aside from Teslas. The green ones are operated by a company called Electrify America, which is a spinoff of Volkswagen that was mandated as part of that emissions cheating scandal years ago that started the Volkswagen settlement. But Electrify America has these fast chargers. Originally they had 150 kilowatt chargers and 350 kilowatt chargers. They seem to be swapping out the older chargers, so most of them now just have 350 kilowatt chargers, which are basically as high power as you're going to find out there. The other mostly yellow squares are lower powered DC fast charging locations, probably 50, 62 and a half, up to 125 kilowatts. So again, until recently, these fast chargers were concentrated in the eastern third of the state and along the I-80 corridor. But in the last year or two, new locations have been established in northern Nebraska. So Chadron out there in the northern panhandle, there's now one in Thetford, one in Ainsworth and O'Neill, as well as chargers in a couple public charging stations in Norfolk and in South Sioux City. So it's becoming easier now to travel off I-80 with an EV. There's still some big areas lacking charging. If you're going to Southwest Nebraska, that's a tough area, but it's getting better. There's more equipment coming as more vehicles show up on the road. And as part of that scenario, the infrastructure law that passed several years ago includes funds for a 5-year EV charging program, which is called the National Electric Vehicle Infrastructure Program, which is NEVI for short. That program authorized allocations to state departments of transportation to build out charging along the national highway system. And it also included a competitive grant program for community charging to be administered by US DOT. Each of those programs had $2.5 billion allocated to it. The highway charging component of this, there are regulations that govern the design of the stations. They have to have 4 DC fast chargers rated at least 150 kilowatts. And the stations have to be no more than 50 miles apart and within 1 mile of the highway. The chargers are required to have CCS ports, and they had to base the payment to the driver, payment from the driver, on the amount of electricity dispensed. So a couple wrinkles here. One of these NEVI stations is a big financial outlay. These are expensive pieces of equipment and expensive to operate. And that last requirement about the payment mode really stalled the work in Nebraska. Until our unicameral passed legislation this spring, only public electric utilities could legally sell electricity by the kilowatt hour, which the NEVI program basically requires. But with that passage, it's now okay for a Casey's or any other commercial owner of a highway charging system to base the pricing to the driver on the amount of electricity dispensed, which is the fairest way to do it. So as a result of that legislation, NDOT has issued a request for proposals to build stations at these locations along the Interstate 80 corridor. And this is another restriction of the NEVI program, was that for the highway charging, states could only use these funds, had to first use these funds to build out any already designated federal EV charging corridor, which in Nebraska is the I-80 corridor. So right now, NDOT can't do anything else with these highway funds until the I-80 corridor is fully built out. And NDOT has designated these locations to be approximate locations of new highway charging stations to be funded through that NEVI program. That's going to take several years. Once that's done, NDOT will be free to put out highway charging along other highways in the state of Nebraska. So we'll see how that plays out in the next few years. Incidentally, the city of Lincoln is currently working on a community charging grant to increase the amount of charging in the city of Lincoln. There have been attempts to organize a bunch of smaller communities around the state to apply for the funding, but those have not really gotten off the ground. There have been kind of too many hurdles and barriers to get that done. So wrapping up here, if you're shopping for an EV, what are things you should consider? The internet and YouTube are your friends. Check those out for the latest information and reviews. After the COVID pandemic, for the next couple of years, shopping for EVs was pretty difficult. Manufacturers couldn't keep up with demand. You couldn't really find an EV in the dealer showroom to do a test drive. A lot of people ordered EVs from the manufacturer sight unseen. Now that's changed. The manufacturing has caught up with demand and sales seem to have slowed in the last year or so. So now you may actually find EVs at your local dealers. For example, the Kia dealer in town has had some EV6s in stock off and on for the last 6 or 8 months. So other things to consider, rear-wheel drive, front-wheel drive, or all-wheel drive. With all-wheel drive, you have front and rear motors. That's going to give you the most power and provide you the best traction on wet or snowy roads. But if you're in all-wheel drive mode all the time, that's going to reduce your driving range, and these cars are a bit more expensive. Again, for driving mode, you could often select whether you want both motors running at the same time, so you can somewhat mitigate the driving range issue by selecting your driving mode. For two-wheel drive, do you want front-wheel or rear-wheel drive? Because of the weight distribution in EVs, most of the weight is in that battery pack, which is in between the two axles. There's not much weight difference between the front end and rear end of an EV. So with EVs, there's not the advantage to front-wheel drive that you would have in a regular vehicle where you've got this heavy engine in the front of the car. And with rear-wheel drive in an EV, the rear wheels only have to provide power to the wheels, and the front wheels only have to steer. So the consensus is that that's probably the optimal choice if you're buying a single motor vehicle, and most of them actually are rear wheel drive. There's only a few that offer a front wheel drive single motor car. Inside the EV, what are you used to? What are the controls? Tesla pioneered the center touch screen, which provides almost all the controls for navigation and cabin climate, infotainment, radio, all that stuff. And Ford and Volvo and some others have adopted that big center screen as well. Personally, that kind of turns me off. Other manufacturers have integrated everything into the dashboard, and some of them still retain some actual physical knobs and buttons for climate control and radio. To me, that's an easier way to ease into this high technology vehicle, and it gives you some, if you got some physical tactile touch, you can maybe do that sight unseen, where a touchscreen, you always have to be looking at it, and that can divide your attention away from your driving. So those are things to consider when you do test drives and look at the vehicles. Some other miscellaneous features. Again, the cabin heating and the air conditioning are powered by the battery, and so running those reduces the range. Some EVs have a heat pump that captures heat from the air and waste heat from electronics to reduce battery drain when you're heating the cabin. So that's something to look for. Most EVs now will have charging locations integrated into the car's navigation system, but that's something to check out if you're looking at the vehicles, and allow you to do route planning directly in the car system, but you can also use your smartphone to do some of those things. What kind of wireless connection does the car provide? Can you connect to Apple CarPlay and Android Auto so your car and your smartphone are connected to each other? And also, does the manufacturer offer wireless software updates? One of the things about EVs is you've got lots of computers in there. It's really a gigantic rolling computer as much as anything else. So all these systems, like the infotainment system, even the battery management system, can be updated through time. So the manufacturer, if they change their mind on how that battery management should work during fast charging, all you have to do is update your software. So can you do that wirelessly while you just sit there, or do you have to go into the dealer and they have to plug in a thumb drive into the vehicle to do the update? And also, for cold weather situations, some EVs offer a battery preconditioning. So when you know you're going to be charging in a half hour, you can turn on that preconditioning and it'll warm the battery up to get it ready for that fast charging on the road and get you in and out of the charging station faster. For a home EV charger, same thing holds. Check the internet and YouTube for the latest information and reviews. If you're driving an EV with over 200 miles of range and you travel a lot, you probably want a level 2 home charger. They come in either plug-in versions or they can be hardwired into your wiring in your garage. Again, the more expensive network chargers allow programming the charging time, but as I pointed out before, you can generally do that in the vehicle. So you can probably get by with a so-called dumb charger. You do want to make sure that there's an automatic restart feature built in, so if the power goes out and charging is interrupted, that charging session will automatically resume when the power is restored. And one of the reviewers of these always puts the cable in a freezer overnight to see how flexible it is in cold weather. So that's a consideration. One other thing to think about is when you're getting the electrical work done, make sure the electrician is knowledgeable about EV charging. If you're plugging in overnight to a level 2 charger, you're drawing that 240-volt current for hour after hour. So you need the highest quality electrical components. It's not just, you're not just running your dryer in your basement for 45 minutes. So you need to make sure that the electrician is using very top-notch components when they wire that in. So there are lots of online resources. I guess you'll have these links available in the recording. We may be able to make the slides available as a PDF file. So those would be live links. So there's a couple different websites here. The Inside EVs website has lots of daily posts and podcasts. Green Car Reports is another. There's lots of YouTube channels with folks reviewing vehicles and charging equipment. State of Charge is dedicated to charging equipment. Tom Malogny is very knowledgeable, does very interesting tests of all these. He also does 70-mile-per-hour range tests of EVs to give you an idea of the driving range. The Batteries Included podcast is another good YouTube channel discussing EVs every week, and a few others on here as well. So there's lots of resources out there on the internet if you're really interested in an EV and home charging. So thus endeth the presentation. So I met my 40-minute
Okay, you met your
target.
goal.
So
Okay, we do have some questions here. I have heard that the weight of electric vehicles will wear out the tires faster than gas vehicles, leading to higher. Oh, okay. Oops. Well, I can't see the. Oh, sorry about that. Okay. The survey popped up. Okay. Leading to higher tire costs and the more rubber left on the road and environment.
well, at least partially true. Yes, EVs are heavy. My EV6 weighs about 4,500 pounds. So they do require specialized tires that are manufactured specifically for EVs to deal with that heavier weight. Whether the tires wear more rapidly is probably going to depend on the tire manufacturer. I don't have any firsthand experience or know of studies that prove that. The tire wear and excess rubber, again, may be true, but I don't know for sure.
Okay. Okay. Another question. I've been driving CCS and Tesla vehicles the past few years. Are you going to discuss the abysmal reliability and availability of public charging, particularly CCS chargers? Unfortunately, I have countless stories about faulted, broken, significantly derated, and more recently, cable theft at public chargers. Poor reliability and availability of public chargers is the #1 issue holding back Nebraskans from buying EVs, in my view.
And that is all certainly true. The cable theft is a relatively new wrinkle. Yes, all the charging networks other than Tesla have to do a much better job with reliability. Electrify America, in particular, has had a lot of problems. They are busily replacing all their original fast charging equipment with newer equipment, which so far seems to be more reliable. But yes, nationally, that's an issue, and part of the NEVI program is trying to mandate at least 97% uptime for chargers. but a lot of work still needs to be done. For Tesla, um, Elon Musk has been doing some strange things over the last year. He kind of cut the staff on their charging component. I mean, Tesla's done a good job of actually having staff that go out and visit the charging stations and check them out and fix things. But Elon Musk seems to be more interested in other matters these days, so it remains to be seen whether Tesla's going to be able to maintain that reliability that they're known for. And also, you see, I mean, that charging map with Tesla chargers looks the same now as it did in 2019. Tesla really hasn't made any effort to get off the interstate in Nebraska and Iowa and other places other than the coast. So we're sort of relying on other manufacturers and other charging networks to kind of fill in the empty space in between Tesla superchargers.
Is there market research that indicates that Nebraska is accelerating the adoption of EVs? Will the state at some point provide incentives?
The last question is a question for your state senator. I don't think there's been any legislation introduced to that end. I haven't been privy to sales figures for EVs in Nebraska specifically. We'd have to get that information from DMV. I think in general, sales of EVs have picked up a lot in Nebraska compared to 3 years ago. I see a lot more EVs on the road. There have been several instances around Lincoln where I've been stopped at an intersection and there have been 2 other EVs in addition to mine. So they're becoming more common. We'll see what kind of acceptance conservative Nebraskans have for this newfangled technology. It's going to take a while.
Can I charge my Tesla in Northwest Nebraska with fast rate?
Tesla will sell you an adapter that lets you use a CCS charging connector. It's not free, but it does work. There are some aftermarket ones as well, but some of the reviews suggest those are not to be trusted. You should stick with the one you buy from Tesla.
Okay. Is there any level 3 charging stations in the process of being built that aren't a part of the NEVI program?
I don't know about being built. A lot of the ones you see off the interstate have all been built with other funds. NPPD had a program that started a couple of years ago to really try to find locations in northern Nebraska, western Nebraska to have DC charging. And NPPD was providing a subsidy to those locations. So NPPD is responsible for the new fast charging stations in O'Neill and Ainsworth, and I think Shadron. Some of the other public power districts have financed DC fast charging in some other locations around the state.
Let me just go here. I think we have, and I think there's a question in the chat as well, but oops, sorry. Come on. How many minutes does it take for you to charge your Kia EV up to 80% with level 2 and fast charge?
Level 2, it depends on the charger. I took a trip to Kansas City a couple months ago to the Nelson Atkins Art Museum. They have level 2 chargers. They're dual port chargers and they share the power. So it's a 6 kilowatt charger, but if 2 vehicles are plugged in, you get 3 kilowatts. So I was plugged in there from like 11 in the morning until about 6 in the evening. and I only got about 40% charge out of that. An Electrify America 350 kilowatt charger. I rolled into Council Bluffs with 13% battery charge left. And in about 20 minutes, I was up at 85 to 90%. Again, it'll depend on your vehicle. A slower charging vehicle is going to take longer, but with these highest power chargers and the newer vehicles that allow higher charging rates, we're getting close to the gas station experience. 20 minutes, have a cup of coffee, walk around, stretch your legs on a long trip. That's not a big inconvenience in my mind.
And we have a comment from Ron Scott. NPPD offers a rebate on installing home chargers.
And I think LES has a similar program. OPPD may as well.
Okay, well, we've got some things in the chat here, and then I know we want to launch that survey at some point, but what are the average costs per hour for charging away from home?
Let's see. Again, most of the chargers have now switched over to charging by the kilowatt hour. So initially they were charging for time, but now they're able to switch to just charging for the electricity dispensed. But for my travels on the interstate in the last few months, charging from 13% up to 85 or 90% was $10. Because our electricity rates are so low compared to fuel costs, it's always less expensive to charge your vehicle than it is to put gas in it.
Yeah. Okay, and Lauren has a comment. I just had my charging cable stolen this week.
Yay.
Apparently that's happening, huh?
Yeah, people are stealing the cables for the copper.
Okay, now we have, can all EVs use the Tesla chargers?
Not at this point. Again, Tesla has produced this kind of adapter that will mount on the charging cable itself and will automatically adapt to either the Tesla connector or the CCS connector, but the rollout of that is very slow.
Yeah. Okay. I understand that EV charging infrastructure can only be built in response to vehicles that are on the road, but it makes it incredibly challenging to be a current owner of an EV who has moved to, let me see here. Sorry about that. To Nebraska. Okay. Is there any way to compile a list of folks who would be willing to open their home chargers for a fee? Kind of like an airfield, but for chargers, or an Airbnb, but for chargers.
Right.
Interesting idea.
Yeah, that I've not heard of. I mean, this is the classic chicken and egg issue.
Yeah.
I mean, you need to have enough vehicles on the road to make it worthwhile to have the chargers, but without the chargers, you don't have enough vehicles on the road. So that's why there are these incentive programs, why the NDEE program was instituted as part of the IRA to jumpstart this technology.
Yeah. Okay, I think we have one more comment from Ron. PlugShare and Electrify America are good apps to have along with your car computer to figure out where the next charger is. So that's
right.
okay.
Right. There's
I
yeah,
think
let me comment on that. So yeah, there's Charge Hub, there's PlugShare, which are public. Most of the car manufacturers have smartphone apps for their car that will also locate those chargers for you.
Okay. I don't think we have any more questions. I think, Ken, if you'd want to put the survey up, we would appreciate it if you could take a few minutes to complete the survey.
Yep, I did. I got that launched already.
Oh, you already did it? Okay.
I did, yeah.
Okay.
When it popped up in front of you, that was the same time I launched it.
Oh, okay. Yeah.
So thanks for everyone who filled that out.
Yeah. And also thanks everybody. Thank you, Randy. That was a really interesting and informative presentation. We appreciate your taking the time, and we appreciate everybody being here. Check out our Facebook page or our YouTube channel for more information about Conservation Nebraska. And I guess, have a nice evening. Thank you, Randy. We really appreciate it.
Well, thank you all for attending.
Thank you. We'll talk to you later.